Well, good morning, everybody, and welcome to Ellensburg, Washington, USA. Or should I say, Wintertown, USA. Beautiful light snow falling here in the Kittitas Valley of Central Washington. This is Central Washington University's campus that you're looking at right now. And as soon as I see that we're 5x5, I will switch it over to me, and we will talk a little bit more. Thank you, Elaine. So coming into the shelf cam that we have, I've got a new camera. It's right there, looking out the window. And hello, everybody, and welcome to this episode. The local time is 11:46 a.m. on Thursday, January 18th, 2024. And thank you for remembering to join us live. We have more than 300 already. That's a little bit unusual, but it's quite active weather-wise. You want another shot? Looks like we're 5x5. You want another shot? Yeah, I mean, the light snow started maybe an hour ago, and I think it's supposed to stay like this all day into the night. We're supposed to get 4 or 5 inches, I think, is in the forecast. And so I walked in this morning because our family van doesn't do that well in the snow. Liz has a Subaru, of course, so she's in good shape, but I've got the old rickety van. And so I trudged in, happy to do so, kind of got my head right anyway to get our show together today. And looking forward to today's episode. I have many new things up my sleeve today, so we will see how it all goes. But first step is making sure that we're broadcasting live and with good video and good audio, and I think we're doing that, so that's wonderful. Where are you viewing from today? Can I say hi to a bunch of you, and then maybe I'll feel better if I describe what's new before we try it, just in case it's a train wreck. I'll just look right here, why not? Chino Hills, where are you viewing from? Portland, Oregon, Klamath Falls, Oregon, Thorpe, Wisconsin, Webb Lake, Wisconsin. Seems like I always notice you guys together for some reason. Warren, Maine, it's probably snowy there. Deering, Kansas, Randall, Washington, Thief River Falls, where it's -3 degrees Fahrenheit. Thank you for that. Zion National Park, Morton, Illinois, scrolling very quickly now. Edwardsville, Illinois, another Portland, Oregon, Martinez, California, snowy Coopville. Okay, Bob and Kathy, that's a little unusual over there, isn't it? DuPont, Washington, Jefferson City, Missouri, Glasgow, Scotland, an interloper in the hallway, Plain, Washington, Rattlesnake Tuff, Boise, Blodgett, Oregon, Redmond, Washington, Vancouver, Washington. Yeah. Good stuff. Boiling Springs, Pennsylvania. Yeah, mostly North Americans, it looks like today. And as soon as I say that, Exmouth, UK. Okay, so thank you for being here. We're approaching 500 live viewers. I didn't think I even said it, but you know the drill by now. If you're watching this in replay, you can go ahead and scrub ahead 10 minutes or 11 minutes to the top of the hour, and that will be the beginning of the show. Okay, let me get this off my mind. It was a week ago today that I had major troubles with the crackly microphone and I gave up. Do you remember? And we did it the following day, whatever show that was. I can't even remember. But we did it on a Friday. That was just a week ago. So since that time, Nat Nickel, the Wonder Boy, the miracle worker, has created this whole new setup for me involving a stream key to live stream. And this is the third show in a row now where there's no problems so far. And I tested things about 4 or 5 times yesterday and the day before. So I'm pretty confident with this stream key thing right now. But my old routine of using Melon is not the best approach for this new stream key setup. So I'm using Zoom today when I interview the guest. You don't have to do anything on your end, but you just sit back and relax, and you're next to the fire and it's snowing outside or whatever. That's all great. But I'm going to be struggling a little bit today on using Zoom, and we'll see how smooth it is, but this is the first crack at it. And I was practicing with it a little bit yesterday. So I've got the Zoom ready to go, and our guest, Mark Sweeney, is in class right now at the University of South Dakota, and he has a meeting in a little bit more than an hour. So his spare hour in his office after class, but before his next meeting, he's spending most of the hour with us. So I'm going to be extra quick to get rolling with Mark because I have a bunch of questions. Okay, so let me check the stations quick. There's the desktop. There's Docky, and okay, we know that. And here we are today with Mark, Thursday, January 18th. And if you want to see the next episode live, Sunday morning at 9 a.m., Jerome Lessman from Vancouver Island University will be here, and I'll explain more detail on that coming in just a bit. And a week from today, Vic Baker from University of Arizona. Okay, good. One more programming note. If you are interested, she insists that she's going to make it here. Kelly Wall lives in Portland, and I think it's 50-50 that Kelly Wall is going to be able to get up here today. Ice storm down there in Portland yesterday, blah, blah, blah. But she says, don't worry about it. She's buddies with Hannah, and Hannah's like, Kelly's coming. Kelly's got four-wheel drive. She'll make it today. So Kelly may be in the middle of driving up here, but my point is, if Kelly gets here, and I hope that she does, there will be a brand new Goat Rocks Volcanic Complex lecture tomorrow. So that's Friday, January 19th at noon, and that's part of our noon lecture series. And special thanks to one of you guys, you're probably watching live right now, lives in Wisconsin, and you called Vindman's Bakery 2 weeks ago and you said, hey, the next Talk Friday, Vindman's, can you bring in all sorts of treats? And I want to treat the whole department to the next social hour that we're having. So Vindman's and Jeff are going to tromp through the snow tomorrow to bring sticky buns, fresh, and cookies and all sorts of things to go with our coffee and tea and hot chocolate. And so thank you to the anonymous person in Wisconsin who made that happen via Vindman's. So that's tomorrow for a Goat Rocks Volcano talk. And if Kelly doesn't make it, we'll go to Plan B. We'll have a talk. We'll have some kind of talk tomorrow. And yes, I'll live stream it tomorrow. I've got to figure out how to get that all set up with this new system, but I'll figure that out. Okay, so that's that. One more quick thing. I'm choosing not to share a lot of the gifts for reasons I don't think I want to tell you, but I'm choosing not to do that. But I have to share this one. Of course, I'm grateful to all of you who are sending things as a note of appreciation. It's almost like back in the pandemic days. But this is from Scott and Sherry in the Sangre de Cristo Mountains of New Mexico. I won't read the whole letter, nice things, but it's basically I've reconnected with my love of geology. I was a former geologist. Thank you for your programs. And I'm now in retirement a woodworker. And so I have created, using wood, Moses Cooley. This is a slab of wood. Made out of New Mexico ponderosa pine. And so, Scott, I have no idea how you do this, but here's the dendritic mature landscape and Douglas Creek coming in that did not have Ice Age floods, and then here's the shot of Moses Cooley. So I will figure out how to use this, Scott. But thank you so much for your generosity. I'll put it to use. Thank you. Okay. Here's the rough part. I'm going to start my hot mic segment a couple minutes early because I'm going to give you a shot out the window, and while you're out the window, I think you'll still be able to hear me. Are we 5 by 5? Can I ask one more time? There's a delay. By the way, there's an extra delay with the stream key. It's the only negative of going to the stream key. There's a bit more delay for me, not you, but for me. But that's because I've chosen to be as crisp as possible with video and audio, and I'm happy to give that up. If that means a couple of seconds extra of delay to, in exchange, have very, very strong AV, then I'm going to go with that. Okay, 5x5. So let me tell you what's going on right now in case you get confused. I'm going to try to connect with our guest, Mark, via Zoom while you're looking out the window. You'll be able to hear me, but I don't think you'll be able to hear Mark. And my plan is that Mark's probably just getting out of class and heading to his office. You're still going to be looking out at the snow, and you'll hear me kind of maybe chatting with Mark with my headphones on, and then I'll take my headphones off. I'll say, Mark, give me 10 minutes, and then I'll start the first 10 minutes with you guys like normal. Mark will be watching via Zoom, I guess, and then we'll try to bring him in. That's the plan. And if it doesn't work, it doesn't work. Whatever. We'll go to plan B. Speaking of plan Bs. Okay? So thank you. Here's to you. Here's to you for joining us today for this episode called Loess. Here's to you. Okay. Thank you. You are looking out the window right now. And I am going to start talking to myself. I'm going to start a Zoom meeting. And it says I'm not connected to computer audio. That doesn't make me happy, but I will just hope for the best. And I am going to invite by email, Mark. And that's going to South Dakota. Is it Vermilion? I guess that's where he is. Okay, I'm going to take my walk, everybody. Give me 2 minutes, hot mic, and by the time I get back from my walk, I hope that Mark will be in the Zoom call with me and that's functional. Thank you for joining us. I'll be back in 2 minutes. Here we go. Hello, Mark. How are you today? Good. I'm getting messages from my headphones here. Am I sounding okay for you? Wonderful. And likewise, how did class go today? Okay. All right. Okay. Well, the plan right now is that I'm live streaming right now. Folks can hear me, but I don't think they can hear you. And I'm just going to kind of have you off to the side. I'm going to go 10 minutes, pretty quick, Mark. I'm just going to try to set the stage for this. We'll bring you in and we'll just go for it. And I've got a list of questions for you and then the live questions as well. And we'll just play with it, okay? Okay, great. Thank you so much. I appreciate your time so much. Okay, let's see. I'm going to talk to myself. Don't end the call. Bring it over here. I'm connected to you, so I'm going to close email. Okay, great. I'm taking my headphones off. Thanks, Mark. Hi, everybody, and welcome to this episode called Loess. It's the top of the hour, and we're ready to get rolling here. And I'm on the clock today because our guest, University of South Dakota professor Mark Sweeney, is needing to get to a meeting within the hour, at the top of the hour. So we have a little less than an hour to visit with Mark. And so I'm going to be extra businesslike to get rolling. Can I ask if we're 5x5, first of all? There's a delay in the chat, but just let me make sure that we're doing okay there. And once I see 5x5, somebody's going to put me on the clock. We're going to go 10 minutes. I think Mark is able to hear me somehow. And I just want to set the stage for this. And then we will I'm sure that we will enjoy our conversation with Mark. Thank you, Oscar. Here we go. Somebody put me on the clock. We're talking about Loess today. And it's high time that we do so because if you recall, our open questions way back at the beginning of this series with Jerome Lessman was, these are the 4 questions I'm working on this entire winter. I don't know if we'll finally solve things, but are all these ice age floods coming from Montana? Are all of these ice age floods younger than 30,000 years ago, which seems to be the typical story that you hear? What is the story with this frickin' Loess? And that's what we're doing today, obviously. And then we have been severely preoccupied with J. Harlan Brett's before 1922, but we're kind of done with that because now the timeline is we are there. So when we're done with Mark Sweeney and our conversation with him, and you'll get a chance to ask some questions. When we're done with Mark, we go right back to Brett's timeline, and today is the summer of 1924, precisely 100 years ago this year. Okay, so how can I set things up for our visit with Mark? Loess is wind-blown silt. It's not a rock layer, it's loose silt, kitchen flour, that is piled up in southeastern Washington. I'm going to give you basically the Geology 101 version, just so that we can all have a little bit of background before we start visiting with Mark. The Loess makes sense to me at a certain degree, but then I lose it. So I need improved knowledge of the Loess, otherwise known as the Palouse. There's a certain very unique landscape in southeastern Washington, over by Washington State University, Pullman, for instance. If you've ever driven in that area, it's very, very unique. And those hills, those Palouse hills, are made out of this loose, wind-blown silt. I don't think we'd have any of that Loess in Washington if we didn't have a Canadian ice sheet creeping down into our state. So there's a 1-to-1 correlation between the Loess ice age deposits and the ice sheet itself. Multiple times, perhaps, whatever, doesn't matter. But I think 2.6 million years ago, at the dawn of the ice age, we don't have any of that Loess. Now, our guest will correct me probably in a few minutes. But it's ice age Loess tied directly somehow to these glaciers that are invading Washington from the north. Okay, you need some visuals because you're watching in Australia and you've never been here. Let's do it. Let's get some images quickly. I'll go nice and big. Not full, but I'll go pretty big. This is what the landscape looks like. It is dramatic, wouldn't you say? This is Loess that's making up these hills. Let's go quickly. I've lost track of the viewers who've sent me certain photos, very talented photographers. Sorry I don't have your names. This is the landscape we're talking about today, and Mark Sweeney has spent some time digging into these hills and publishing papers on the Loess. Daniel Coe, Washington Geological Survey, with some very unique imagery. Possibly you will use a few of these things today when we talk to Mark. Okay, you get the idea. I mean, at first glance, you'd think these are a bunch of sand dunes, but they're not sand. They're silt, finer particles, kitchen flour. These are just my photos with an iPhone. Like, if I'm driving around, I stop every once in a while, I got to get a photo of this stuff. I'm not even a big photo person driving, but this landscape, if you catch the right day and the right weather and the right puffy clouds and all that, it is just a magical place. This is the Loess sitting directly on top of the German chocolate cake. And by now we know that the chemistry of the silt has nothing to do with the chemistry of the basalt bedrock. So this is not just a soil that's the result of breaking down the bedrock underneath. This ain't basalt. This ain't granite and gneiss. So from Vic Baker and other classic papers, the concept is, once upon a time, and here's where I'm teaching Geology 101, and I say, listen up, 101 students. Once upon a time, early in the Ice Age, whatever that means, we developed a huge, thick pile of loess, up to 250 feet in thickness in certain places. And the questions will come from the students. Well, how'd the loess get there? And I'm like, I don't know. It's just there. It's somehow related to the Ice Age. And I go, I need to learn more. And then once we establish that on top of the basalt is this blanket of loess, then you bring in some Ice Age flooding and you remove most of it. And so the idea is that Bretz, back in 1922 and 1923, was on foot or by train and was tromping around out here and noticing that there was islands of loess, and here's more loess over here, and he's mapping the boundary, this sharp boundary between these steep slopes of loess, he called them loess scarps, and these places that we're driving on that are naked basalt. That's the scablands. So Bretz is realizing that there's a dramatic here or not. Loess is here, loess is gone. Loess is here, loess is gone. Why is the loess gone in so many places? That, in the early papers from Bretz, is the evidence of these cataclysmic floods of water, an outrageous hypothesis that an incredible amount of water swept most of this loess away. And some of these images are coming from these beautiful books by Bruce Bjornstad. So this is what I've taught, that knowing the Loess hills is fine, but understanding and assuming that the loess is old Ice Age material, and then late, quote unquote, in the Ice Age story, you bring the water in to remove a bunch of the loess. And that has power, that has beauty, and the students can understand it, and they're like, oh shit, there's I-90, and there's Ritzville, and there's Spokane, and I'm driving right through a place that used to have loess and it doesn't. So again, these are maps from Vic Baker, I believe. All these stippled areas are places that have loess. All these white areas, the loess has been completely removed by the Ice Age floods. But I'm caught. I'm caught because it's not this simple. We're going to our guest right now, and he has dug into these hills and has found multiple generations of loess. The loess is not all the same age. So until Mark's paper in 2012, I taught that story without a heavy conscience. And since 2012, I've been bothered because I don't totally understand why there's multiple stages. One more thing, Mark, and then I promise. One more thing. So I want to remind you of our color scheme because we will probably use it today. From our work with Joel Gombiner and many others. Oh, I'm excited. We decided from Joel's marine isotope stage records that we have 4 major glacials in the last million years, according to the stuff out under the waves of the Pacific Ocean. Stage 16, which I'm coloring brown, 650,000 years ago. Stage 12, purple, 450,000 years ago. Stage 6, blue, 150,000 years ago. And stage 2, 20,000 years ago. We learned that from Joel, that there, out of all of the advances and retreats of the ice worldwide during the Ice Age, according to the marine isotope stage record, we have 4 biggies with these dates coming from Joel Gombiner. Now, you know what I've been trying to do. I've been trying to decide what's the age of the Spokane flood or the Spokane ice sheet over Spokane. And this is Western Washington versus Eastern Washington with our color scheme, red, orange, and blue. I'm just going to use shorthand today. We'll be doing a lot of just color talk today, and I'm going to assume that you know what I'm talking about. What are the colors one more time? Red means stage 2, 20,000 years ago. Orange means stage 4, 65,000 years ago. Not, according to the marine isotope stage, not one of the biggest glacials. Stage 6, 150,000 years ago. That's the context for our discussion today because, I'll just tell you verbally, Mark's paper in 2012 says we got a bunch of loess that's orange. We got a bunch of loess in the Loess Hills that are stage 4. And that's evidence of glaciation in the Spokane area, where we can't seem to find much till or moraine material. Okay, I'm going to click on Zoom, bring in Mark, and hope for the best. And I need headphones. Mark Sweeney, how are you today?
I'm doing great. How are you?
I'm so pleased that you're with us. Were you able to hear what I just did?
Yes.
Okay, terrific. Let's get started as I kind of futz around a little bit here. Where did you do your schooling, Mark, and what chapter in your life were you doing the work in the Palouse?
Yeah, so I grew up in Phoenix, Arizona, and I started at Arizona State, but I transferred to the University of Nebraska and got my bachelor's and master's there.
Okay.
And then I did my PhD at Washington State University with Alan Busaka and David Gaylord. And so I was first shown Loess by a Loess researcher, Joe Mason, who's at University of Wisconsin-Madison. And, I wasn't that impressed with it because it's so fine-grained and it's not too exciting to look at. But my PhD work, I really gained an appreciation for this fine stuff.
And,
yeah.
And was that, so your paper came out in 2012. Who were your co-authors on that paper?
The co-authors on that paper are Eric McDonald and Alan Busaka.
So Busaka was on your committee maybe for your PhD. Did you just say that?
Yeah, so he and David Gaylord were co-advising me. So
okay.
David, the dunes, and Alan, the Loess.
And how did McDonald get into the picture?
So McDonald was Busaka's master's student back in the 80s, and I ended up doing a postdoc with Eric after I left Washington State.
Okay.
So yeah, we've got a interesting little family working on Loess up in Southeast Washington, and I should say both Alan and Eric did a lot of the work leading up to this. Alan recognized the great age of the Loess. There's reversely magnetized Loess, and his work with Eric recognized that the Loess had been eroded and by previous floods, pre-stage 2 floods, and that potentially a lot of the Loess was derived from the flood deposits in the first place. So I built on their work.
This is exactly where I want to go. So this is terrific. I mean, ideally, we'd have all those guys on together, but you're going to be a spokesman, I suppose, for those folks. One more kind of preliminary thing. You're doing great, by the way. This is wonderful.
Thanks.
Have you moved on from the Palouse? Like, are you still studying Loess, and how many areas globally have you been looking at some of these deposits?
I'm still involved with the Palouse. I ran a GSA field trip for the 2017 meeting in Seattle.
Oh, yeah.
And then we've got some loose ends we want to tie up. And I've worked with people out of the University of Washington to look at stable isotope signatures from the Loess. But since then, I've looked a little bit at the Peoria Loess and Holocene Loess here in the Great Plains. And then I did have an opportunity to go to China in 2013 and and have a look at that, but not study it directly.
Okay. Well, so I'm just going to go for it here. You can pass on certain things. You can go, hey, I've got a slide that maybe would help if I answer this question, however you want to do it. But you've seen enough of these programs to know that it's mostly just this. And I hope you're okay with the live viewers asking questions in a bit as well. Viewers, I'm guessing, I'll keep an eye on the clock, but I'm guessing maybe 15, 20 minutes of me and Mark, and then we'll go another 10, 15 with you guys, and then Mark's got to run. Okay. Let's start with my earliest statement here. If we're back 2.6 million years ago and we don't have any ice history in the Pacific Northwest, do we have any Loess here, Mark, in the Pacific Northwest?
Not sure. So the stack of Loess, very deep in some places, up to 75 meters, does have reversely magnetized Loess. So Alan Busaka hypothesized, and there's Loess below that it goes back at least 1 million, if not 2 million years old. That we haven't been able to age date the oldest Loess. I don't know that we've actually identified where the oldest Loess is, but there's a possibility that it goes back throughout the Pleistocene, but certainly we've got Loess that's 1 million-ish years old.
Okay. We'll come back to that, but how about kind of rookie questions related to that? So if we're going back more than 2 million years, do we need an ice sheet nearby to generate the silt? Are we saying that all of that Loess is coming from some sort of ice sheet nearby in the neighborhood?
So in terms of the big, thick Loess packages around the world, most of them are associated with glacial phases.
Yes.
Because it's the glacials that create the rock flour that gets deposited out in front of the glaciers and then blown by the wind to create the thick Loess sheets. There are Loess deposits in the world that are associated more with desert environments, because we know deserts are very dusty places, but you need to trap to hold the silt in place for the Loess to accumulate.
Okay.
So I would say up in Washington, you could have had some dust blowing around, but you weren't going to get the really thick Loess accumulations until the glaciers started going.
Is there some sort of cardinal rule about you've got a pile of Loess in one county and the ice has to be less than 4 counties away or something like that? Is there a proximal relationship with the Loess and where the ice was sitting?
No. So take the Peoria Loess and the Midwest Loess, for example. You have Loess accumulating on the downwind side of the Mississippi River all the way down to Louisiana. And so you're way far away from the glacier there. The key thing is the fluvial drainage, the river that was transporting all of that silt. Yeah. And of course, once the Mississippi River drainage became a thing, it was transporting huge amounts of sediment from the glaciers to the north, way far south, in order to produce the Loess down there. So Washington is an approximal location now.
Yeah. Okay. So that's helpful. So is it too crazy to say that even though this is wind-blown silt, all of that wind-blown silt had a prior water chapter? Like, to go from the ice to the wind deposit, is there some sort of intermediate step where you've got water flushing it away from the glacier?
Yes, I'd say that's accurate. That's how I would see the Palouse situation.
Okay. And in the Palouse situation, we're back to Brett's now, so it's not just lazy rivers flushing this silt out. We got these big floods that are they're chocolate milk, basically, right? They're silt-laden waters.
Yes. Yep.
So is that why the silt is piled up to the east of the scablands in general, or to the east of Lake Loess, or what are some key spots to help us anchor into the Washington map with how you visualize even these oldest Loess deposits being accumulated?
So you did show some Loess Islands.
Yeah.
And so those were very close to the scabland tracts. Yeah. And so you had erosion leaving the islands behind, but the farther east you go, away from the flood channels, the coulees and whatnot, that's where you get the most continuous and the thickest Loess accumulating. And so that's kind of why you find it down there. But also the loess is accumulating downwind of the large depot centers for fine-grained sediment from the floods. So where the floods were getting constricted behind Wallula Gap, for example, there was large amounts of fine-grained sediment accumulating in the basins there, Walla Walla Basin, Pasco Basin, Yakima Basin, and those served as the sources of dust that eroded, from those basins and then accumulated in the Loess areas downwind.
Oh God, this is great. Viewers, I'm going to keep going I'm going to be selfish. I want to keep going in my train of thought, and then we'll go where you want to go, which is maybe more basic and broad. But, okay. So ultimately, the origin of the Loess is coming from underneath the ice. So the origin of the particles are north of Spokane, as opposed to, why do I keep hearing people talk about like the Ringgold might be the source of the Loess, or the White Bluffs or something like that?
Right. So you can't rule out the Ringgold. So we did do some geochemical studies on that, and the Loess overlaps in composition with the Ringgold. And the Ringgold happens to sit in some of those depot centers and could have been, more available for wind erosion in the past. But the outcrops aren't very extensive. And to create the pile of Loess that we've got in southeast Washington, you need a lot of fine-grained material. And so that's one of the reasons why we've got our eye on the flood deposits there as the major source. And they match geochemically, the Loess and the floods match geochemically.
So where is the glacier grinding up the rock to make the flour? Is it up in Canada ultimately?
Canada, Montana, anywhere the glacier was. And so if the source of the water is Lake Missoula mostly, we're dealing with, rock provenances in Montana and up in Canada. And then when that water gets released and transported into southeast Washington, it's transporting maybe some sediment with it from the lake, and then it's also eroding anything that's there that has been draining in front of the ice sheet prior to the outburst flood occurring. So any of the drainages, the braided rivers that were probably there at the time serve as potential sources for this silt that yes, was basically ground underneath the glaciers and then brought out through water.
Hey, you're good. You're just good, okay? I'm going to keep going just because you're right on point with these answers. Thank you. Have you or others then gone through the Palouse Loess and decided how much of that 250 feet of Loess is Canadian bedrock and how much is Montana bedrock? Is that even possible?
So I think after I left Washington State, there was some students that attempted that. And, I didn't see anything that was pretty, definitive that said maybe, subglacial sources that were more west versus glacial Lake Missoula sources that were east of there. So, we don't have a lot of insight there.
Yeah. But the general concept is that regardless if it's water from Canada or water from Montana or wherever the source of the water, whether it's outburst or not, the general idea is you're getting that water down to Lake Loess in south central Washington. You're draining the water away. It goes down to Portland and beyond, and then you blow a bunch of that silt to the east. Do I have that basic scenario correct?
That's correct. Yes.
And even I think that's where the confusion is for me and maybe many, that this, I don't know if it's in your work or not, but this recycling business of you blow the silt back onto the Palouse and then the next flood comes and brings it back down. That works for me, but I kept saying, how about originally? Like, I get that you can recycle it, but where's the Loess coming from originally? And that was always my bugaboo.
Yeah, that's a great point to make. So, I've only focused on the upper few layers of Loess, and there are many more. Each layer of Loess is separated by a buried soil. And we know that, so if you look at the Loess that's there now, the upper unit of Loess, which is 15,000 years and less, post-glacial flood, if you go right below that, there's a whopper buried soil there that we call the Washtenaw soil that has every indication that it formed entirely during the coldest phase of the last glacial maximum.
Okay.
And then there's a pile of loess below that. And then the next big whopper soil we call the Devil's Canyon soil looks just like the Washtenaw soil. Every indication that it formed during stage 4 cold glacial conditions. And then there's a loess layer below that, and another soil, and another loess layer, and another soil. And so the upper two layers of loess that we call the L1 and the L2, the L1 is about 4.5 meters at its thickest, just downwind of Eureka Flat, north of Walla Walla. Yeah. And then the L2 below that is 9 meters thick. So the older loess, the loess that accumulated since stage 4 and into stage 3, is thicker, but just as extensive as the most recent loess. And so they're identical geochemically. They have the same features in the loess and the buried soils that are in them. And so since we have such a strong linkage between the most recent loess and the last outburst flood cycle, we also interpret that the loess unit below that must also have been from outburst flood deposits, hence stage 4. There must have been a stage 4 advance producing floods to produce the same exact thing that we got after the stage 2 floods.
Wow. Well, your paper kind of talks about that. That's the meat of your paper.
That's the meat, yep.
And viewers, you have that paper to read if you want to dig in. But you're saying there's 2 or 3 more stories below that you haven't looked at.
There's more than that.
More than that?
So, yeah, there are so many soils and loess units that go back, more than 1 million years. There's a couple outcrops that have really nice long histories. We need to go. So the problem has been age control. So we can use luminescence dating to date the loess in the upper part of the section, but only recently have techniques gotten to the point where you can probably date much older loess, going back 100, 200,000 maybe. And it's hard to date the older stuff. And I think Bruce Bjornstad dated some of the older flood deposits using uranium. And maybe we could do that too with some of the carbonate soils in the older loess units. But that's the problem, trying to figure out how old those lower loess units are. And which isotope stage they connect with. We don't know that.
Is there any stage 6 that anybody's got in the list so far?
We've got some luminescence dates that suggest there's stage 6 loess, yes.
So you've got red, orange, and blue, all 3 of them in many of those loess hills in southeastern Washington.
Yes.
So how come nobody's talking about those older ice advances over Spokane then? Do you have any comment on that? Like you've seen these episodes. I keep wondering why all the attention is on red. All the attention is on the last glacial with ice over Spokane, or not even getting to Spokane. From your work in the Loess, you can pass on this one. You've got 2, 4, and 6. Does it seem reasonable to you that there was an ice sheet over Spokane in all 3 of those times, or 2 of those times, or 1 of those times?
That could be. I don't know if ice has, right. There could be a lot of scenarios in the past. Maybe the ice wasn't configured just the same way. But I do feel, based on the loess evidence, really strongly that we've had some form of ice age flood occurring, in the previous even numbered, oxygen ice mentioned before. And I know in your conversations with Jerome, this has come up, and others, that nobody can find the stage 4 slack water sediments, the fine-grained slack water sediments that would have been the source of the silt that would have created that older loess unit. And so, and the stuff that they're doing out in Moses Coulee and other places, they're getting all the age control on the floods are coming back stage 2. And, other than the stuff that Bruce has worked on, that are much older. We don't have any definitive deposits that date to that time, but that doesn't mean they don't exist or didn't
Right.
exist, because we
Right.
know that the floods were very erosive, and maybe they're buried somewhere and we just haven't found them yet. But I think they were there or are still there somewhere. In order to create the piles of loess that we've got, we need extensive, flooding occurring, depositing fine grained sediment over a wide geographic area to create the incredibly thick loess sheets that we've got between stage 4 and today.
This is so beautiful. Viewers, we're coming to you in a second, but Mark, give me a crack at this. So it's like in the Loess Hills, and I think you're comfortable with my colors now. Hopefully you do. So you've got red, orange, and blue, 2, 4, and 6. Here we are in 2024. We've only got red in Glacial Lake, Missoula. We have no Glacial Lake, Missoula evidence at all that goes orange or blue. And you're just saying that down in Lake Lewis country, to upwind of the Loess deposits, we just have red. We don't have orange or blue yet, I guess. Although I think Bjornstad said he had a couple of slackwater sediments along the Yakima or something that were older. Do you have any? I don't know.
I remember, it would be nice to chat with him.
Yeah.
I've seen older flood deposits, but I just don't know how old they are.
Right.
So
right.
I've seen them in the Uretha Flat area, and they're stratigraphically right below the stage 2. They make sense that they'd be stage 4, but we haven't dated them to know. So they look like they're right age-wise, but they could be older yet, right? So we until we can date them, we don't know.
Okay. How about the idea, a little curveball for you, and then viewers, get your uppercase ready. How about the idea that occasionally there are floods going through the Loess Hills and scouring, like it's almost like a more subtle version of a coulee where you're excavating loess? Is that what those unconformities are telling us?
Yes. So the flood cut unconformities in the big loess areas, they basically, water must have started overtopping them and eroding right through them to create the unconformity, and then loess accumulated after the flood had passed. And we've got tephras, volcanic ashes, and age dates to kind of help say they were likely stage 4.
Okay. Well, I see Bruce is in the chat. Bruce says there's older than 780,000 rhythmites at the Yakima Bluffs in the Tri-Cities. Okay, well and Sky's here too, Sky Cooley. Just finishing that thought. Nobody's tried to map those flood-scoured unconformities through the Loess. That's probably impossible to try to get a three-dimensional sense of where the water's coming from.
You need outcrops, and so that some of the big ones are along Highway 26 near Washtenaw.
Yeah.
In fact, funny story, there was one up by Ritzville that Eric McDonald and I looked for to showcase in the 2017 field trip, and they had already published on it, and we're looking around and we think a quarry took it out. So that outcrop is gone. Okay. And there's another one by Canal, and so there's a few outcrops out there that have these. But so you basically got a couple of data points, and it would be really hard to map them three-dimensionally.
Yeah,
I think.
Totally. Yeah, I mean, it's delicate stuff. You can't expect it to stick around for much. Viewers, uppercase, please. Put your caps lock on. We'll come to you, and Mark did have a few slides. Maybe at some point he'd want to bring those in. I'll just grab what I can see. Sky Cooley wonders, how thick does windblown silt need to be before it's called loess?
Yeah, I think there's a little debate about that. Between where you have, dust additions to soils that get worked in before you get a substantial thickness. And I think if you get a couple tens of centimeters of silt, I think you can call that loess.
Fair enough. Sharon in Malaga wonders, are there any cascade sources for the Loess deposit south and east of Wenatchee from the Leavenworth glaciation? That's out of your purview maybe, but do we imagine some Loess coming from the Cascade somehow?
Yeah, I don't know that for sure. I
Yeah,
suppose it's possible, and I would imagine if Loess came from that area, it would be very locally deposited near, where those channels would have been draining those glaciers.
thank you. Keep it rolling. We're catching you just on a spare hour, right, between class and your next
Yeah,
meeting.
yeah,
Like,
no, I'm good.
have
Yeah.
you had lunch today?
Yes, I had lunch and I've got
Okay.
coffee, and so
Okay.
I'm good to go.
Okay. Are you in Vermilion, by the way? Is that where the university is?
Yes, I am. That's
Okay.
where University of South Dakota is.
That's damn near Iowa, isn't it?
Pretty close.
Okay.
Yeah.
All right. Kenneth in Sandpoint, Idaho wonders, glacial lakes are pretty blue due to the particle size. Are glacial ground silt a unique size? Glacial.
Yeah. So some of the main components of Loess is basically 20 micrometers and coarser, but a lot of Loess has 20 to 30 micrometers in size. So within silt, which is less than 63 and greater than 2 or 4 micrometers, depending on who's counting.
Okay.
But yeah, 20 to 30 is a really common size to be produced by glacial grinding. You can produce it all, but that's a common one.
Love it. Sean says, could the evidence of stage 4 and stage 6 simply have been removed by stage 2 flooding?
Why not? I think that is certainly possible.
That is the theme, I think, through many of these areas that we're looking at in this series. Rachel wonders, how is magnetic reversal determined in Loess? What are the paleomag techniques?
Well, you, yeah,
That's not
so
you,
they've
that's
tried
not you.
that.
Yeah.
Right. Well, they've tried it. It doesn't work in the Palouse. Let's just say that. It works in China. It doesn't work here. They've tried it looking at, well, so you can find magnetic reversals, but I'm sorry. I'm also thinking about magnetic susceptibility, and
Okay.
sometimes you get accumulations of magnetic minerals and ancient soils. That doesn't happen here. So we do have the magnetic reversal. So you have to carve out a little block of Loess, and you have to, with a compass, note its orientation. And then back in the lab, you measure it. And I've never done that. But so you have to be very careful when you excavate that little block if you want to determine the reversely magnetized Loess. So sorry, I think I misunderstood what she was saying at first.
No, we got it. Yeah, it's similar. We did a series last winter on Baja, BC, and paleomagnetism of bedrock units in the North Cascades. Same idea, right? You're drilling in, or you're sampling, and you use that Brunton to measure the orientation of that core before you take it back to the lab.
Yep.
Les, what is the wind speed necessary to make this wind-blown silt?
The common threshold wind velocity to get particles moving by the wind is 5 to 6 meters per second.
Okay.
So, yep.
Good. Papagino, how do we know where the glaciers ended? Where did they start, and did they produce Loess from the outset?
Yeah, well, we know where they were based on the moraines that kind of outline the edges of the glaciers, and we know they came from the north somewhere. I think glacial modelers have mapped out where the tops of the ice sheet domes are.
Yeah,
so I guess I would say that's where they came from.
Good. We're at 20 minutes to the top of the hour. You got another 10 minutes, Mark?
I've got 10, 15
okay,
minutes.
Thank you.
Sure. Mm-hmm.
Russ wonders, do dunes of Loess have a characteristic shape? Like, is it wrong just to call the Palouse Hills a bunch of dunes?
Yes, it's wrong.
Okay.
and yeah, we had lots of conversations about this. So the Palouse Hills do look like sand dunes.
Yeah.
So in a sand dune, you have the Stoss side, which is gently sloping, and then you get to the crest, and then you get the steep leaf face out front, and the dune is moving in this direction. And so you do get these asymmetrical hills in the Palouse Loess, but it's from landsliding. So you get snow preferentially accumulating on the north faces of the hills, And then you get clay translocating into the soil, creating a slick surface. And I've seen it. I went out with Alan Basaka to see these when I was there. And you get these little landslides on the north sides of these hills, which creates what used to be a relatively smooth shaped hill to one that has a steep north face and a shallow dipping south face. So they look just like dunes. And that a lot of people misinterpreted the Palouse Loess as a field of dunes, but it's not. Dunes are very specific landforms formed of sand grains, whereas the Loess is, gently settling silt out of the air, accumulating on a vegetated landscape.
Very good. A few more. Kent wonders, what is the role of katabatic winds? What is a katabatic wind?
So where you get big ice sheets today, there's a big temperature difference between the ice sheet and the land out in front of it that creates a wind that comes off the ice sheet, and they can be really strong winds. And so some people thought that there were some pretty strong winds coming off the Cordilleran ice sheet during the last ice age, and that may have been the case, but they did not seem to influence the transport and deposition of loess in the Palouse area. I wrote a paper on this that was published in 2004. So we referred also to these as anticyclonic winds. And so in Washington, the anticyclonic winds would have been going from east to west, and the Loess doesn't record any evidence that was transported that way.
Right.
And we know that because the Loess is thickest closest to the source area, and it gets thinner downwind, and it's also coarser. It has a little bit of sand mixed in upwind, and then it has more clay downwind. And everything is coarse near the slackwater basins in Pasco, and then it gets super fine-grained and thin as you go up towards Spokane. So we know that the transport direction of the wind was always from the southwest, but during the ice age, the ice sheets probably shut off that prevailing southwesterly wind. And that's why we got these really strong soils developing in the Loess at that time, the thing that we call the Washtenaw soil. So there wasn't very much dust accumulating at the height of the ice age.
Fascinating. I'm going to take the last question, and then if you have any more time, this is your call. If you have any more time after my last question, then we'd like to see a few of your slides. But if not,
Sure.
That's fine. Pretty thick Puget Lobe over there in western Washington. How come there's no loess over there, Mark?
It could be the climate conditions. So one of the things that we haven't talked about is that you kind of need an arid and a windy area to basically generate the dust. And south central Washington is one of the most arid parts of that region, right? Because you're in the rain shadow of the Cascades.
Yeah.
And so during the Ice Age, it was arid. There was sagebrush steppe in that area. There still is there now, but it was more expansive then than it was today. And so after you deposited the slackwater sediment there must have been a fair amount of time before vegetation colonized it. And it was arid, and you had the prevailing southwesterly winds blowing the dust up into the Loess. If you go out to the Puget Sound area, it's rainy, it's moist there. The climate is different. It's not nearly as windy. And so the conditions just aren't set up to basically blow anything around.
Bonus question from me, or you can view it as a bonus question, maybe not. So before the Cascades lifted, when we had low Cascades, we didn't have the dramatic rain shadow. Does that mean we wouldn't have had much loess accumulate using that logic?
I think, that logic seems pretty sound. So if you had higher precipitation back then, presumably the vegetative cover would have been higher, and then you wouldn't have been able to erode any of the silt, except from very localized areas.
Oh, wonderful, wonderful. Well, it's a quarter to the top of the hour. How you feeling? You got time for
Sure.
a few slides?
Sure.
You can do the maiden voyage here of sharing your screen to see if this even works.
Okay. Yeah.
Go for it. Thank you, Bruce Bjornstad, for being with us, and thank you all of you for those excellent questions. Okay, we are if We're seeing the presenter slide thing again. Yeah, there we go. Nice, beautiful.
All right. Yeah.
Well, however you want to do this, and however you keep an eye on the clock, Mark. Whatever you're going to cut yourself off here whenever you feel like it.
Sure. So,
Yeah.
this is the general setting. I think everybody is really, uh, familiar with this. I was going to see if I could get that little
Oh yeah,
laser pointer.
yeah. That's
Right, yeah, there,
a nice,
there we go.
beautiful, good. Yeah, we can see the red dot. Good.
So, if the sediment is coming in the direction of the black arrows, the wind in red is blowing it back in the direction that it came
Right.
from. And
Right.
so the main depot centers of fine-grained sediment are shown in that olive brown color there.
Yep.
So these would be your major dust sources. And associated with those in black are sand dune regions. And this is a critical component to get that dust picked up.
Yeah.
So when the little sand grains bounce on the ground, they liberate the dust particles into the wind flow. And so the sand dunes are a critical part of this. You need them to basically loosen up the silt to then blow back and accumulate in the Loess Hills.
Huh.
So that's the setting. And then this is one of our classic Loess outcrops. This is called Clyde. And that's David Gaylord there. He's about 6 feet tall, but that's an awful lot of dust, right? And so I was mentioning the two most recent Loess units, the L1, which is 15,000 years and less. There's a nice Mount St. Helens Set S tephra that's right at the base of that. And then the L2, the next oldest Loess, is here, and it's capped by this calcic paleosol that we call the Washtenaw soil. And there was a researcher that did a study on opal phytoliths, which is similar to pollen analysis, and that's why we know it was arid when the soil formed, because it's loaded with little sagebrush opal phytoliths and the burrows of cicadas, which feed on the roots of the woody shrubs. Huh. And then if you go below that, it looks the same. It's just a repeating cycle of Loess buried soil, Loess buried soil, Loess buried soil. Huh. And these soils, many of them represent arid conditions that likely formed during the Ice Age. Let's see. How do I advance now? Oh, there we go. Oh, yeah. So if you want to see some nice flood cut unconformities, this is on Highway 26 coming up out of Washtenaw Coulee before you get to Sandhills Coulee.
Yeah.
And this picture is old. Eric McDonald gave it to me, but it looks almost the same. Some of the outcrops that Eric McDonald dug out in the 1980s have been grassed over, and so they're hard to see. But this one, the wind helps scour it and keep it open. And this is the interpretation. And so this is in that 2012 paper that Nick posted on his website. And you can follow along. We've got some tephras here. The Mount St. Helens Set C tephra is up towards the top, and that dates somewhere between 30 and 50,000 years. And then we've got older Loess units below that, and going back, way back.
Yeah.
And so these heavy black lines, these are the flood cut unconformities. And so right over here, this is a coulee right there.
Yeah.
That was formed during the last set of floods, and that's what sculpted the side of the hill there. So you can get a really nice sense of things at this outcrop.
So potentially down there with E and F, we are way older than 1 million years.
Possibly, yeah.
Okay.
That could be.
Okay.
Could be, yeah, several 100,000 years old, because these are even older yet.
Wow.
These ones over here.
Okay. Wow. Great.
And then, yeah, I just wanted to show these. This is the last slide that I have. These are based on Eric McDonald's and my measurements of Loess unit thickness throughout Southeast Washington. So the area we're covering is in this box here. And this is the L1 Loess. So this is the most recent Loess unit of the past 15,000 years. And then this is the Loess unit that's below it that was formed presumably from the stage 4 floods. And one of the reasons why we're arguing for stage 4 floods is so if the water came from somewhere else, if it came from the Columbia River, or if it came from the Ringgold, or if it came from a subglacial flood up near Moses Coulee or something like that, it would be hard, I feel, to redistribute sediment to the slackwater basin shown in the green area, enough of it to produce a 9-meter thick loess deposit. That's a pretty thick loess deposit. So we interpret that as only being possible if we have a big flood coming from Lake Missoula. Maybe we're wrong, but the similarity in the thickness and distribution of the two most recent loess units suggests a similar origin.
Interesting.
Yeah.
Okay. Wow.
Yep.
Yeah. If you want to stop your share there, and I just thought that was just so great. I mean, you have a lot of practice talking about Loess. I know that, and you teach daily, so that helps as well. But extra thanks, Mark, for watching a few of the episodes leading up so you had a sense of what we were trying to do here. And you've done us a great service here today, so thank you so much for your time.
You're welcome, and thank you for involving me. I've been enjoying seeing what people are talking about with regards to the most recent, going all the way back to Brett's and following him. That's been amazing. And then just seeing what people who are researching in the area have to say about the most, recent work to come out.
Well, we'll keep up with you too. And are you doing something at the Cordilleran meeting in May in Spokane?
I plan to, but it's more about the salt sand dunes than Loess. But
okay.
Yeah.
Okay. Very good.
But we may have some Loess papers coming out in the next year or two.
Oh, I hope so.
Yeah.
Okay.
Mm-hmm.
Well, thank you so much for your time, and have a good rest of your day, Mark, and we'll see you again sometime real soon.
Thanks a lot. Take care,
Okay.
everybody.
Thank you. Bye.
Bye. Bye.
Okay. Somebody's got the door open or something to the building, like there's incredibly chilly air coming in. So let me give you a shot out the window. Let me collect my thoughts. We're going to go back to Brett's and do some summer timeline stuff, but give me a second to get my head right. Would you please? Well, the camera's frozen, isn't it? That's a nice touch. Let me try Shelfie. That's still working. Yeah, okay. I swear the snowflakes are still falling. They're not frozen in suspension in the air. Okay, so are we 5x5? Yeah, our building, on the north side of the building, our offices have been without heat all week. We can't even get an explanation about what's going on, why they can't come over and help us out. So I'm going to put my coat on for the rest of this, if you don't mind. We're not about to quit. I got easily another half an hour or more. I wanted to get that. We front-loaded the episode. Maybe all the guests should be like that. I should keep my mouth shut and get them on sooner than later, but we're 5x5. Good. Okay, so we're done with the headphones. We have our normal routine. And, yeah, there's a whole bunch of stuff to share with you. And I hope that you want to keep rolling with this. You know these shows get longer and longer. I hope not to do it for... Okay, let's go. Let's go back to the slides. Oh, I got to get rid of the Zoom thing. Oh, hang on. If I end this, that's going to end the Zoom, right? Exit full screen. This is Zoom. I don't have to keep this open. Well, I don't know why. I'll just hide it. No, stop it. End the Zoom call. You're done. Okay, Zoom's done. All right, so back to a comfort zone now. Good. So, yeah, I'm done with my 101 teaching, and I have a bunch more detail. I just thought that was an outstanding effort by Mark. Hope you enjoyed that. Yeah, different versions from different publications showing the channeled scablands and showing where the loess remains. And even today, there's dust storms and haboobs and all this sort of stuff that gets the loess deposited back there. This is just in case we didn't get to it. These are images from the 2012 paper from Mark and his group. And I was distracted by a couple of things, so I'll enjoy watching the replay. This was the oldest stuff, right? And I think what I meant to ask, but I didn't, is, well, I think I know the answer. I wanted to know, let me switch back. I wanted to know, ultimately, he's got loess from red, from orange, from blue. I'm gathering from him that they don't have the techniques yet to for sure say stage 12 or stage 16 in the loess. But the reversed paleomag stuff is 780,000 years ago. And the work from the Joel Gombiner says if you look just at the marine isotope stages, we've got the 4 big ones. We don't really have major glacials going back earlier than 780,000 years ago, which I find kind of interesting. So in case you're losing it a little bit, I don't know whether I color the Spokane ice sheet blue or orange now. He's got both blue and orange in the Loess Hills. So let me try this with you. I had some fun with some Sharpie markers last night. I got papers everywhere now. Hopefully this is not too disjointed. Still kind of reviewing our time with Mark. Yes, Brett's is saying, look, before the Spokane flood, this is Brett's now. We're transitioning to Brett's 100 years ago. Brett's in 1924, Brett's in 1923, Brett's in 1922 even is saying, I've got this loess on top of basalt. Originally it was a continuous mantle of loess, but Brett's is saying, I'm just going to assume that all this loess is really, really old, and all of the loess is older than any of the flooding. Remember, Brett's was just talking about one big flood. And so he says this loess has to be older than the Spokane flood. And then when I bring the Spokane flood in, says Brett's, I know the Spokane flood came through here because the loess is gone, and we have these very steep scarps on the edge of the Loess Islands. And in some places, I know that the Spokane flood not only took the remaining, the continuous loess away, but it also cut into the basalt as well. That's not what I wanted to show you, though. These were my questions that I was ready to go with Mark. Did we get to all of them? What's the origin of the loess? Is all the loess greater than stage 2? Why did I even ask that? Well, he says he's got plenty of stage 2 in the Loess Hills. He's got volcanic ash layers to keep track of time and some newer techniques as well. No stage 2 water in the Chini. Oh, I forgot to ask that. So Brett's hit pretty hard the idea that when you finally get to the Wisconsin glaciation, red, there's no floodwater coming down the Cheney-Palouse Scabland track due to a bunch of field relations and elevations and things of that sort. I meant to ask Mark about that. And, okay, we got to everything else. Still not to what I wanted to show you. Here it is. Remember my scissors trick like 3 weeks ago or whatever, where I took out the Spokane ice sheet, and what the hell happened to the Spokane ice sheet and the Cheney ice sheet in Washington? Why do we have red, orange, blue for sure in western Washington? Why are we only talking about red in eastern Washington? Still don't have what I want. What am I looking for? Here. So I am, when we started this thing back in November, I didn't know how the letters were going to play out. You know that. And I had a strong suspicion that we would dive into certain things, but I didn't really know what we would dive into and what would just naturally be a place that we would dig deeper and deeper, no pun intended. I think it's official. I think the position of the ice margin in the Spokane area has become our biggest obsession. I don't know how you're feeling. And I don't really know if the Loess generations are helping us specifically locate ice margins. In fact, I'm sure they're not. But it's a step forward today that we have 3 generations of Loess, red and then orange older than that, and then blue older than that. And so it's not crazy for us to go back and keep wondering about 3 generations of ice sheet over Spokane. So I finally found what I wanted to share with you. So this is the one that we've been looking at to this point, right? This is John Stockton's house in Spokane. We've been using blue, I've been using blue as the idea of the Spokane ice sheet encroaching south of Spokane. And again, modern maps, modern geologists are saying this. Look, you want to talk about an ice story in the Spokane area? The last 50 years of geologists have said there is no blue ice to talk about. It's a red ice story, and it never got even close to Spokane. Well, here's a third choice. Because Mark Sweeney has a bunch of stage 4 Loess, that's a player now. And is our Spokane ice sheet over John Stockton's house stage 4 ice? And is Bretz's Spokane flood that he is documenting in 1923, 24, 25, and 26, is that an orange flood from an orange ice sheet versus a blue flood from a blue ice sheet? And you're like, I don't understand why you're so obsessed over this ice margin business at Spokane. I'll give it to you verbally. How do I do it without making people mad? The company line is the ice sheet never got over Spokane, and therefore all of the Ice Age floodwater coming over Spokane and into all of the channels of the channeled scablands, that's red water, that's stage 2 water, all coming from Glacial Lake Missoula. But if we get stronger and stronger in our investigations as to find an orange ice margin or a blue ice margin south of John Stockton's house in Spokane, you know how that changes things? That means we have an ice sheet sitting right at the head of these pathways. That's the difference. We are sending Ice Age floodwater directly from an ice sheet into a scabland. It's not coming from Montana. It's coming from Spokane, Washington. And suddenly, yes, we're talking about eucalypts, and suddenly we are talking about subglacial flow. And we're back to the bias of Canadian versus American on how you want to deal with your water. Do you want your water skirting around the front of a glacier to the south of a glacier? And the lake was here and then the spillway, and it's all... How do you like your water? How do you like your Ice Age floodwater? Under a starry sky? Subaerially? That's the American take. Or do you like your fast-moving, energetic Ice Age floodwater subglacial, in the dark, underneath ice? And what we're trying to do, what we're wondering about is if we see enough evidence by reading Brett's and flint, which will come in the next few letters, then suddenly we have a lot more ice much, much closer to the channeled scablands, much, much closer to the Loess Hills. And if we get that ice back where it was in orange and blue times, then it makes a much stronger case for subglacial flow. There, I said it. I got no horse in the race, but it's pleasing to me to have a uniform story along the southern margin of a Canadian ice sheet, whether it's red, orange, or blue. And therefore, we're back to Moses Coulee. We're back to the Grand Coulee. We're back to the Columbia River Valley south of Chelan. Are all of those Ice Age floods during stage 6 or stage 4 coming out from underneath the ice sheet? And then once we get to the red time, as I've said a million times now I agree. The red is not coming towards Spokane. The red ice is not covering Spokane. And the red ice is allowing all that wonderful data in Glacial Lake Missoula to have the Missoula floods. I'm not saying the Missoula floods never happened. I'm just saying I wonder if the earlier chapters of Ice Age flooding is a totally different mechanism for generating the water. Or at least a different source. And not Glacial Lake Missoula. All right, I'm scared to look at the chat now. I maybe lost some people. This is radical talk now. But that's where my mind is, and that's why I'm caring so deeply about this Spokane area, way more than I ever thought. Never mind the fact we got Google Maps by Glenn. He's continuing to work in this. He lives in Spokane. We've got some geologists now who are watching the programs, and they're getting together and going out in a foot of snow and looking for some of this stuff. Pantops, blah, blah, blah. Get back to it, boy. Get back to the slides. That was too much of a freelance. Let's go. Yeah, this is all waits for you in Mark Sweeney's paper 2012. 2012. L1, L2. I'll let his conversation with it speak for itself. All from Mark's paper. And he does have stage 2 flooding, Lake Loess, Wallula Gap, but he has stage 4 floods. Mark Sweeney, our guest, he's got blue floods coming from, I'm sorry, this is orange. He has orange floods, stage 4. Okay. Collect our thoughts. The rest of the episode is pretty much scraps in the kitchen. A whole laundry list of things I want to share with you. Things that have come in through my computer from viewers in the last few days. Things I've meant to do with you earlier. Sharing an original thought related to that ice margin in Spokane, and then getting some reaction from some of my buddies by email. Let's do it all. Thank you. Oh, God. Disjointed. Let's go to the web. Let's go to the web. Very quickly. So if we... What's going on? Thank you. If we click on floods, Brett's has 2 papers from 1924. Age of Spokane Glaciation. That's the famous Talus paper that became a major target of criticism, and I think eventually Brett's backed off of it because of the criticism. I don't know how much we'll talk about that today. I made some videos last summer about it, the Talus business. The Dalles. Brett's in the gorge is noticing all the intricate scablands near Celilo Falls and the Dalles in the Columbia River Gorge, and wrote a paper on classic Ice Age flood scouring. And even in his other papers, he would talk about Dalles-type channels. Our friend Thomas Large is writing a paper, but I'm not doing much with it because I feel like it's kind of a detour for us. I don't know if it's helpful for our narratives. And then we're not to summer of 1925 yet. So those, I'm sorry. Why am I including this? Why do I have this paper in here? Oh, it's published in 1925. So this paper exists. It's based on the summer of 1924's work, and we're going to look carefully at this map, which is dramatic and revealing, I think. And then there's Mark's paper, Mark Sweeney's paper, waiting for you. And then I'm going to fold in this paper by Chad Pritchard from Eastern Washington University today, looking at the West Plains. And then Alberta Gary created some beautiful custom maps for us related to the Spokane area, working mostly with Brett's original work. So all those things are simply under floods. And then, of course, if we go to Brett's, you know what I mean by of course, today we're doing 1924. So there's Brett's typed field notes, there's Brett's field sites, Google Earth by Glenn. There's Sharon with some newspaper clippings about Brett's 1924, Thomas Large and Friends 1924, and then those papers are there again. Okay, pick up the pace. Pick up the pace. Hide it. Let's go. Yep, got it. Yep, 1923, summer field season of 1920. Am I getting confused? 1922, excuse me. This is from Joel in Sacramento. Thank you, Joel. Now that we know about the Loess, here are all these white areas that are Loess covered or unmapped, says Brett's in 1923. But if we go back, this is downtown Spokane. Here's our ice sheet sitting on top. This is blue. We're coloring it stage 6 for lack of a better thing. Should I be coloring this orange as well? It's possible. Look at all these lakes. Do you know Eastern Washington? Do you know all of these crazy lakes that are everywhere seemingly in the Scablands? Every black dot is a lake. This is Sprague Lake. This is Cow Lake. What else do you need? A lake over by Wilson Creek. These are the lakes that are in the lower Grand Coulee. The lakes that are, our kids used to drive with us from Ellensburg to Spokane. It's a 3-hour drive, and they're just going berserk at 2.5-hour mark. I'm like, look, we got some lakes. We're almost there. If you see some lakes out the window, that means we're very close to Spokane. Well, these lakes, kind of right by Cheney, the exit to Cheney and Medical Lake, quote unquote, is right before we get to our ice margin. We're gonna zero in on that right now. Letters from the Eugene team. This is from Joseph Pardee to Thomas Large, November 1923. Received your letter of October 27th. And basically, Pardee is saying, I don't want to publish on the Ice Age floods. This is how I'm reading this. Joseph Pardee was invited by Thomas Large to come to the Spokane area and lend his professional opinion on the Ice Age deposits surrounding Spokane. And Pardee came and spent 6 weeks, and Brett's came a month later. Pardee, for reasons we'll probably never know, but as I'm reading these letters, I'm realizing, for whatever reason, Pardee says, yeah, I'll publish a paper on the Spokane area, but I'm going to go back to the Miocene. I don't want to deal with this Ice Age flood stuff. So this letter from Pardee to Large is not exactly apologizing, but it's saying, yeah, I'm reading. Oh. Pardee is saying, yeah, I'm dealing with Dr. Knowlton and Miss Burchett, and we're collecting leaf fossils, and she's collecting leaf fossils, and I think I prefer to just mostly talk about the Miocene, mostly talk about the Columbia River basalts, mostly talk about the lake beds that are underneath. And I'm not going to publish much on the Ice Age floods. This is Thomas Large, also from the Eugene team. Thank you. From W.A. Rocky. I don't know who that is. Is that a joke? the Cordilleran drainage of the time of Wisconsin glaciation. Stage 2, red, and its relationship to the formation of Lake Pend Oreille. I'm including this here today for us because he's referencing Daly, Pardee, Bretz, and others, and they are talking about ice, later glaciation. Oh, there's something in here, but I don't feel like going. Let's skip it. Okay, important letter. I'm jumbled here, but please hang with me if you can. Summer of 1912, let's do it. Summer of 1924, where is Bretz? If you go, am I going to break the live stream if I go to our live stream right now? I think I need to. So this is what it looks like, I guess, when I'm live streaming on my YouTube page. I'm going to try this. Because I need to go to this to get down to the description. There's a link. I'm going to do it real quick in case the audio goes freaky. Live stream, if I go to our live stream right now. There. I think I need to. Okay, so that's how you get to Google Maps by Glenn. And if you haven't caught it yet, today's episode, the past 2 episodes, there's a paragraph of text right down below this video that you're watching right now. And there's the date, and there's how many views there are, and there's something about the title of this episode. And then below that, it says Google Maps by Glenn. And that's the link on how you get to these Google Maps by Glenn in case you don't want to deal with the Google Earth, which I'm kind of half afraid of at this point, Glenn. I'm sorry I said that. So if we go to Google Maps by Glenn, many of you I've seen in the live chat and others are like, finally, I can do this. I really don't want to deal with Google Earth, but Google Maps I can do. My computer can handle it. So I'm turning off all the other summers we're not talking about today, and I'm just turning on 1924. So this is the 3rd summer in a row that Bretz is out here with a new batch of University of Chicago students. And where is he going? Look at this. Summer of 1924, Bretz is staying with the Snake River between essentially Lewiston and Clarkston, Idaho, Lewiston, Idaho. He's on the Snake through Washington, and then Bretz is no car yet. He's still using a train and foot down the Columbia again. So if you recall the show with Jim O'Connor, I'm like, okay, Columbia submergence. Bretz in 1919 thought that there was salt water flooding the Columbia River Gorge all the way up to Chelan, Washington. And then a few of you were like, when did Bretz change his mind and realize it was fresh water that wasn't static, but actually big floods of water? And I think the answer is 1922, immediately. 1923, for sure, as he's mapping the floods, the Loess scarps and the channels and everything else. But in 1924, Bretz is like, I'm going to double check this. I'm going to take my crew of students this summer, and we are going to, Glenn can help us know if it, I don't think they're starting up here and going downriver necessarily, but they are in the gravels. They're looking at the terraces. Terraces made out of gravels, the basic gravel fill that sits in the Snake, a special spot for Bretz, at least in the summer of 24, but I think he kept coming back, was at the mouth of Palouse River. So if you look in here, we've got Palouse Falls State Park, some of you know. This is just Google Maps now, right? I can't do Street View and all that easily, I don't think. But Hooper, and look at this Palouse River, doink, following a very old fracture set in the German chocolate cake. But my point is, where the Palouse River finally enters into the Snake, Bretz visited for sure in 1924, Riparian. This is the part where he's talking about Perry. Is there a little settlement there called Perry? I think there is. At this Lions Ferry Bridge, the Snake River Grill. So my point, I'm getting bogged down now, but my point is that this place is an area that I thought that I was going to go to a lot. I didn't know where we would go in this alphabet series, but I thought the mouth of Palouse River going into the Snake was going to be a spot we would go to over and over again, because Brett's kept going back to Perry. But I think I'm going back to the Spokane area, and that's the last thing we're doing here today. One of the last things we're doing. Okay, so that's Google Earth by Glenn. Thank you, Glenn, for that. Slides. Man. So that sets up this at the end of the summer of 1924, in fact, November. So he's back in Chicago. Let's read this letter. Apparently the one and only letter that Brett's sent to Thomas Large in Spokane. Dear Mr. Large, I was in Spokane last summer, only long enough to change trains, so I had no opportunity to learn that you are not at home. I chased the Spokane flood from Riparian to Portland! And believe you me, it left marks! Priceless stuff from the Eugene team. It was at least 500 feet deep in Wallula Gap, and it overflowed the tops of the cliffs here. Its work is recorded all the way to Portland and is most strikingly set forth there. A paper just finished on it will appear in an early number of the Journal of Geology. I'm sending you a copy of my Talus paper, just out. Will you do me a favor, Thomas? To wit, send me a copy of the SP&S timetable in which altitudes for train stations are printed. I need some of those figures, and the SP&S offices ignore my return address and stamp of envelopes, which I send them with my previous appeals. Very best regards, Brett's. And then like a couple days later, Dear Large, don't bother. SP&S came across in the next mail. Yours, Brett's. So that was 1924. And 3 years earlier, this guy's thinking that it's static seawater going up the Columbia. So this is quite an about face. And as Jim O'Connor said when he was a guest, Brett's never writes, I was wrong. He just moves on. And I think that's worth pointing out because he eventually gets off of a singular Spokane flood. And I don't think, but I may be wrong, I don't think he ever emphatically states in a paper, hey, by the way, 10 years ago I was talking about a Spokane flood. I was wrong. There's a dozen floods. There wasn't just one. I don't know if that's worth following through or not. Now we're to the meat of what I wanted to do with you here before we quit. Look at this map. Do I have a more... I'm really scattered right now. Yes. So this is the key map from the 1924 paper. And it summarizes his 1924 work. I guess it's the 1925 paper, but it summarizes the 1924 field work. Portland's down here, the Dalles, Wallula Gap, Ringgold Formation, as we're talking about today. Those are the John Day beds of Israel Russell. And the channeled scablands, as mapped by Brett's and his students the previous 2 summers. And these white areas are where we have undisturbed Loess that Mark Sweeney was talking about today. But look what I don't know about you, but my eye is drawn here. Let's zoom in on that. So to me, this is an enormous deal. I think you've heard this in the general way that the Brett story is told. He kept emphasizing the scablands, the details in the scablands, all of his measurements, all of his elevations, all of his divides being crossed, needing a lot of water, but he didn't speculate in print on the source of the floods, or the flood, the Spokane flood. And this map is exactly showing that. By now, he's got 3 summer field seasons under his belt, 22, 23, and 24. And he just stops these channels. Every one of them. He just stops them. Including here. Now, what do you do with that map pattern? You just go, okay, I mean, yeah, he just stops him. He loses the channel. He loses the scablands. He loses the Loess. He loses all that stuff. Well, in the text at least, Bretz is saying there's a reason that these things are being stopped right here. They're being stopped right here because there's a frickin' ice sheet right here. This is the ice margin that is in direct contact with the channeled scablands. And yes, in print, over and over and over again, Bretz is firmly saying in the first half of the 1920s, there's water coming directly from the Spokane ice sheet, dumping into these channels. The water's coming from out beneath the ice. These are eucalypts we're talking about. And before I forget, that's our next episode. On Sunday, Jerome Lessman will be back for a 3rd time this winter. And Jerome and I will talk about places that Bretz was looking in the summers of 1926, the summers of 1925 and 1926. Bretz spent the lion's share of 2 summers with his students north of Spokane, and crossing the border into Canada, trying to find a place where lavas may have created a bunch of water by melting the underside of the Spokane ice sheet. So maybe now you can kind of see why I'm so obsessed with this ice margin story in Spokane. And it's not going away. There's too much here to share. I haven't even shared some of the viewer stuff yet that plays on this theme. I'm having a blast. Hope you are too. Yeah, so it's this crucial area right here between downtown Spokane and the head of this channel. This is no man's land. And I want to quickly, as quickly as I can, talk about this area. Bretz, 1923b. The unique combination of topographic features, the Columbia Plateau, has only one interpretation consistent with all foregoing items. The channeled scablands are the erosive record of large, high-gradient glacial-borne streams. The basalt plain, please remember that phrase, the basalt plain is the key spot that he focuses on like a laser between downtown Spokane and the head of the scablands, the basalt plain. The basalt plain records the southern limit reached by the ice sheet from which these streams took origin. Before this glaciation occurred, the entire plateau of eastern Washington was covered with a loessial soil, varying in depth from a few feet to 200 feet. This and the underlying basalt has been eroded to maturity and a network of drainages lines to cover it. The major water courses of this mature topography were consequent on the warped surface of the plateau, which descends in a general way from the northeast to the southwest. The ice sheet approached, talking about the Spokane ice sheet now, blue or orange, not red. The ice sheet approached and invaded the plateau from its northern high margin. It barely crossed to the headwaters of the consequent drainage. In places, it did not cross, but by blocking all other escapeways, its waters were forced to cross. By about a dozen different routes at different altitudes and distributed along more than 150 miles of the ice front, water entered the mature drainage systems. He's basically using words to paint a picture of subglacial flow from an old ice sheet long before the Wisconsin Advance, long before red. The capacity of the pre-existing valleys was wholly inadequate for the volume of most of the streams. Furthermore, gradients were high, and the glacial waters eroded enormously, sweeping away the overlying loessial material, crossing low divides and isolating many groups of the maturely eroded hills to produce the anastomosing pattern of the scablands, biting deeply into the basalt to make the canyons and rock basins and spilling into the Snake River and the Columbia River in 3 times as many places as the pre-existing drainage had used. The conception above outlined is amply sustained by every feature and relationship of the scablands. All other hypotheses meet fatal objections. Yet the reader of the following more detailed descriptions, if now accepting the writer's interpretation, is likely to pause repeatedly and question that interpretation. The magnitude of the erosive changes wrought by these glacial streams is nothing short of amazing. The writer confesses that during 10 weeks of study in 1923, each newly examined scabland tract reawakened a feeling of amazement that such huge streams could take origin from such small marginal tracts of an ice sheet, or that such an enormous amount of erosion, despite high gradients, could have resulted in a very brief time these streams existed. The basalt plain north of the scablands, this physiographic feature, this is Brett's in 1925, this physiographic region extends westward from Spangle for 50 miles along the south side of the Spokane River and varies from 3 to 12 miles in width. It is determined by the upper surface of the Columbia Basalt Formation. It is interrupted in places by short valleys, tributaries to the Spokane River, and the different portions are known as prairies. This plain is bounded on the south by the channeled scabland and maturely eroded Lucille Hills. The differences between it and adjacent broader scablands are not marked, but the Lucille Hills are in striking contrast with it. I'm leading to something, I promise. These hills, which elsewhere on the plateau come right to the edge of the Snake and Columbia valleys, nowhere overlook the Spokane Valley. You still with me? This guy says, look, we've got this plateau, this Columbia Plateau, and on the west side is the Columbia River, and things are draining to the Columbia off of the plateau. It's like a big billiard table. And to the south is the Snake River. Look, I was just there in 1924 with all my students. There's all this water draining to the south to the Snake River and draining to the west to the Columbia River. But on the north side of the Columbia Plateau, I'm Jay Helen Brett's talking to you right now, off script. On the north side of the Columbia River Plateau, there's no loess as you approach the Spokane River. There's loess as you approach the Snake to the south. There's loess on the plateau as you approach the Columbia to the west. Where are those loess hills as you approach the Spokane River to the north? Brett's has an answer. They terminate abruptly on the southern margin of this plain. On the plain, there is no mature topography or no channeled scabland. There is no area on the plateau like it. He's talking about the basalt plain. The nearest approach to it is the northern portion of Douglas County, back of the Wisconsin Terminal Moraine. This narrow plain must be the result of conditions which prevailed no farther south. Here we go. These conditions can be summed up in one word: glaciation. This is a novel and thoroughly unfamiliar way for Brett's and us to imagine where an ice sheet once sat. He's saying this basalt plain was under the ice sheet, and there's no loess hills, the topic of our meeting today. There's no loess hills on top of the basalt at the basalt plain immediately west of Spokane because the frickin' ice sheet plowed it away. Snow? The loess is like snow with a frozen camera. The loess is a pile of snow, and the snowplow comes through, the ice sheet comes through and plows that loess away, strips it clean. We're removing loess from the basalt plain up by Spokane, not by floods of water, says Brett's, but by the ice itself. These conditions can be summed up in one word: glaciation. Deposits of till and many striated erratics have been found in every township examined on it. The till is patchy in distribution. No moraine margins the southern edge of the plain, and no good moraine ridges occur on it, though here and there is morainic topography. The genesis of this basalt plain thus established, the question of its character before glaciation and the method of its development arise. These are answered clearly when the adjoining mature Loessian topography is studied. The larger valleys of this topography have been eroded to varying depths into the basalt. The bottoms of such as lead out across the basalt plain to the north are lower among the hills than the general surface of the plain. The profile of the basalt plain, extended back among the hills, cuts their slopes somewhere between hill summits and valley bottoms, and this transection is at the contrast of loess on basalt, the ice sheet which covered the plain. Therefore, simply removed the upper, weaker formation and only to a minor extent altered the surface of the basalt formation. I'm still building to something, and it's now. If you're still with us, congratulations. We got less than 900. Let's keep rolling. Daddy's excited. This is the area that got plowed by the ice sheet. The loess got plowed away, not swept away by water, says Bretz. And that today is called the West Plains. That today, between Spokane, the city of Spokane, and Reardon, is where Fairchild Air Force Base is, and the Spokane International Airport. That area, West Plains, is a key spot for us now. This is the new paper, new-ish, published in 2020 by Chad Pritchard and others from Eastern Washington University. Why am I excited about the paper? Here's downtown Spokane. Look, here are the heads of these Ice Age flood channels. Here are step toes, meaning here are knobs of old bedrock poking up, but the loess islands are just downstream of here. So we've got this weird disconnect. I thought the ice margin was way north of Spokane, but the head of these flood pathways are down here south of Spokane. How do you bridge the gap between the two? What is between the two things? The answer is the basalt plain, but here it is. Thank you for waiting. According to groundwater studies tracing polluted water in this airport area, Pritchard and others have found old channels that are under younger stuff. Old channels, paleo channels, that have been filled by younger sediments. This stuff. This is the gravel pit I've been talking about. The Excelsior gravels are sitting in older channels, paleo channels. And here's a more detailed spot of, this is the private pit that we saw, that last photo, if this means anything to you. JC Sandbox Pit. So I've showed this to you before, but now we're looking at it with a new set of eyes. This is Bretz's basalt plain, where he says the old ice, whether it's orange or blue, is encroaching over this area, south of Spokane, getting right to the head of these channels, as Large was talking about as well. But now we realize there are channels that are cut into the bedrock here. And why are you cutting channels into the bedrock if the ice is here? Well, according to Chad Pritchard's paper, he says, well, we got some channels that we're going to fill with these gravels. And Chad, nice guy, he's hosting the GSA meeting in Spokane in May. Chad in his print is saying, well, it must be like before the Missoula floods, I guess, that we have these channels. Maybe it's back in the Miocene. Maybe it's some sort of, incised thing where we had uplift intensifying erosion. Why can't we just say it's pre-stage 2? And why can't we say that these channels, these paleo channels that are on the basaltic plain, why can't those be carved during orange or blue time? We continue with Chad's cartoons, and he says, okay, well then when you do bring in red water, stage 2, Missoula water, fine, we're going to fill those paleo channels that are carved in the bedrock with these younger things. I'm fine with that. But I want to know when and who did the carving of these paleo channels. I want to know about this. In Chad's paper, it's just like, yeah, these channels are here. Now the real story is filling them. I think the real story is when and how were these pre-existing channels cut? And maybe Chad thinks it's interesting too, but doesn't have enough data to publish on it. So it's these channels. Here's a modern place. Here's I-90. When you drive from Ritzville, you get a burger at Ritzville, and then you're approaching Spokane on I-90. And here's the Spokane International Airport, and here's the Air Force Base place. Here are these West Deep Channel, East Deep Creek Channel, Airport Paleo Channel, Marshall Paleo Channel, Airway Heights Paleo Channel. They're down there. Why are they down there? Why are those channels there? We're back to the same image, but to me, this is tremendously exciting. Now, I might get off of it, but for right now, I'm wild about it. This is a beautiful map that is not coming yet in this series, but it's about to come. This is in 1928, and I simply want to show you on this map. Here's the basalt plain between the edge of the Spokane ice and downtown Spokane. And our paleo channels we were just looking at are bridging the gap between pantops, basically, and the margin. So this leads me, I'm running long now, but I don't care. This leads me to a wild thought I had staring at the wall on Monday night. Just like zoning out, Bijou's in my lap, and I'm like, are we looking for the wrong kinds of deposits to prove that an ice margin was in an area? Like, is it maybe just a Midwestern approach that you're looking for moraines? Maybe we should look for something else. You've got an ice sheet. What am I doing? You got an ice sheet back in the Midwest. I was taught that you're at the edge of an ice sheet back in the Midwest where I'm from. You find the moraine. You maybe see some outwash out in front. There's a bunch of loess that's downwind, and we're good. That's classic. And it does feel like many geologists, it's happened in this series. We've had a few guests say, I just don't see the till. I don't see the moraine in the Spokane area to prove that ice was over the city of Spokane. I just don't see the till. Well, I appreciate the candor, but I'm wondering if we're just looking for a moraine, is that the right approach? We decided, didn't we, that Brett's and others have not found big, broad, beautiful moraines in Western Washington. We had mostly outwash, aprons of outwash with these flat-topped things. So that's what this photo is. This is Tom Foster gussying up an old University of Washington image, and we're at North Bend. I know I'm skipping around now, but I'm in Western Washington. Here's Mount Si, and here's the Puget ice sheet. And where's the huge moraine here? According to most that study Puget ice, there's a bunch of drift, there's a bunch of outwash, there's a bunch of sand and gravel, but there's not a dominant moraine like you find in Illinois, I don't think. And so when you advance the slide, boy, we're still around North Bend, you've got these flat-topped glacial drift deposits. Of just a view from the top of Rattlesnake Ridge, looking up the middle fork of the Snoqualmie River. Here's where you stop and see all those huge semis pulling off exit 34. There's not enough places for them to sleep. They're sleeping in the on the off ramp. I was confused by these flat top things. I kept thinking, is this a moraine? Why is it so flat topped? And then I realized most of it's not moraine. We're at the ice margin, but it's not moraine. It's not till. It's just a flat-topped, broad outwash apron. And so look, I'm no expert in any of this stuff, right? I'm just a teacher. But I like thinking original thoughts, and this is a forum where I can just explore ideas. And that's all we're doing. We're just exploring ideas. And the idea now is, should we be looking for tons of outwash aprons in the Spokane area as opposed to a big moraine to prove that? And now that I got you here, if Alberta Gary is still with us in the live chat, inspired by what we've been doing, Gary decided to spend some time making some maps of the Spokane area using Brett's details, and Gary has some map making abilities to take modern maps and put some of Brett's details on those maps. And I'm going to read this to you. You can read it too, but I'll read it to you while you're looking at it. This is a direct quote from Brett's 1923. The precise limits reached by the earlier ice sheets, plural, more than one earlier ice sheet, are as yet unmapped, but enough is known to indicate the latter of the two, in other words, the Spokane ice advance, crossed the Columbia and Spokane valleys from the northern highlands, pushed well up on the rim of the plateau, and in the vicinity of Spokane advanced south of the rim divide as far as Spangle and nearly to Cheney. No prominent morainal margin now exists, if one ever was formed. But the till, the striated erratic boulders, the deposits of outwash material, and the drainage channels constitute adequate evidence of glaciation. So Gary took that and ran with it. Gary, are you here? Thank you for doing this, man. Really fun. I saw you posted this on Facebook, and then I asked through Facebook if you could email it to me, and you said, look, I already emailed you these maps like 3 weeks ago. I guess you can't find them. And you're right. I lost them. So thanks for sending them again. And you've got these maps by Alberta Gary at nickzentner.com. So Gary's taking Brett's first channeled scablands map where he has the Spokane ice sheet. Gary, I took my blue marker. I could have used orange, I guess, and outlined the margin. This is the winner for me, Gary. And again, I colorized it. Hope you're not pissed. Red. I think everyone agrees. This is going from Wenatchee, Washington to Spokane, Washington, over to Sky Cooley's house in Montana. And I think everybody agrees that the most recent glacial advance, red, 20,000 years ago, here's Lake Chelan, Withrow Moraine, didn't come anywhere close to Spokane. I think everybody agrees that. But here's Brett's blue or orange ice margin. And what I'm playing with right now is, do we really need a monster moraine to prove this southern margin? Or can we take this family of features collectively as a new way to talk about where the margin was? There's plenty more in here that I don't have time for, including Pantops. But remember, we had Brett's original version of this. Gary took it, put the Spokane blue ice in, Layton. Now, suddenly I don't care that much about these proglacial lakes. Maybe I should, but I don't think I care about them. I think I'm visualizing mostly water coming out from underneath the ice. Yeah, there. I'm with the crazy guys. I'm with the crazy guys. Everything must go. We bought too many. Everything's got to leave this lot. I'm TV Crazy Lenny. Downtown Spokane. Bring the Spokane ice right to the heads of these channels, not because we've got a moraine here, but we have channels abruptly stopping there. We've got Loess Hills that are suddenly gone where they should be. We should have Loess Hills going all the way to the Spokane River. Where are they? They're gone. We can assume those Loess Hills were there all the way to the Spokane River. What happened to them? Nice job, Gary. I'll let these speak for themselves. The most zoomed in one is the last one. And even Gary, Alberta Gary, is like, what's up with this linear thing right here? It was under the ice. That's one of those paleo channels, Gary. You stumbled onto one of these paleo channels that were just published on in 2020. I think this is the Marshall paleo channel that's got the Excelsior gravel sitting in it, apparently. So it's this kind of thing that I was really hoping for. This kind of meeting of different points of view, some professionals, some amateurs, some old, some young. Really fun. I got to wrap this thing up, don't I? Let's go back to the slides. I don't know if are we doing live Q&A? Yeah, we're almost done. So, right. Summer of 1924. I think this is a student. Remember, we're looking for student names when we can get them. Anybody feel like looking for a student? F.L. Pickett. Was he one of Bretz's students in the summer of 1924 and agreeing to be the photographer that summer? Here he is again, including our isolated Loess Hills. And another one of these aeroplane photos in the 1925 paper. Don't be confused, right? 1925 paper means we're summarizing the summer of 1924. Here's maybe yet another student from the summer of 1922, C.S. Reeves. And then, yeah, I'll read it, 1924, Bretz. The northern part of the Columbia Plateau, Basalt Plateau in Washington has been glaciated at least twice. During both glaciations, the drainage from the southern margin of the ice sheet was deflected southward across the plateau. During the earlier or Spokane glaciation, blue or orange today, the volume of the waters was very great, and the plateau's southward slope was severely scoured along dozens of huge channels. During the later or Wisconsin glaciation, that's red, the volume of escaping waters appears to have been far less. I didn't dream that up. Older, bigger, smaller, younger. I screwed it up, but I didn't dream it up. That's directly from Bretz. He's saying the older stuff's bigger, the younger stuff's smaller. Due to this lesser volume and the failure of the later ice sheet to reach as far as the earlier, only 2 of the older glacial drainage ways were used. I cannot stop. It's official. I'm getting loopy, though. I can't keep track of my buttons. So, yeah, Pardee publishes in 1925, but he avoids the Ice Age like the plague. Some nice maps. Here's the only thing Pardee wants to talk about from the Ice Age in his 1925 paper. Pardee. Large deposits of unconsolidated or loosely coherent gravel occur in Spokane Valley and the valleys of Latah Creek and other streams. These deposits lie upon the eroded surface of the rocks previously described, the Miocene in other words, and are mostly of glacial origin. In the valley of Latah Creek and Lake Creek near Marshall are large terraces at an altitude of about 2,300 feet, built of gravel that contains much basalt and here and there a boulder of the fossiliferous shale. This gravel was deposited during a comparatively early Pleistocene stage of glaciation, described by Bretz as the Spokane glaciation. The ice advanced from the north, crossing 5 Mile Prairie, Pleasant Prairie, and other areas from which it plucked masses of basalt and shale. So just when you think that I am on this tangent and I'm just trying to like push a narrative, I'm trying not to push anything. But let's keep score here. Is it just peer pressure that we have Thomas Large, Harley Bretz, Joseph Pardee, all in the same area, Spokane, at the same time, the 1920s, all talking about an older ice advance south of Spokane? So now we flash forward to the 1970s and 1980s where everybody just says that's not a thing anymore. Now we're throwing out three people's work, not just one. Seems weird to me. That's all I'm saying. It just seems weird. Yeah. Brett's as bold as he's going to get probably in 1925. That the Spokane flood occurred is clear. That it was short-lived and waned very promptly after diversion around the northern margin of the plateau seems probable. The exceptional conditions which caused it are still obscure. All phases of glacial behavior considered, the writer at present can conceive of only two possible explanations for this flood. One is a very rapid and short-lived climatic amelioration in which warm winds and warm rains produced great surface ablation of a much fissured ice sheet before the front of the ice retreat from the north of the margin. I screwed that up. Before the front of the ice retreated from the northern margin of the plateau. Apparently no such climatic change is recorded elsewhere, and the rapidity demanded seems impossible of realization. The other possible explanation is that the Spokane flood was a gigantic yokullap, such as have occurred in Iceland repeatedly when volcanic activity has broken out beneath the cover of an ice cap. But nothing has been found in the literature to suggest Pleistocene volcanism in the area which drained across the Columbia Plateau during this episode. So that's what he does the next 2 summers. He goes looking for young lava that erupted in British Columbia that possibly was the cause of the Spokane flood, and quite very possibly was the cause of the incredible floodwater that carved all the big coulees in eastern Washington. So who are we going to get to help us to learn about potential sources of lava erupting under the Spokane ice sheet? That's right. That's Sunday morning. Probably need to call it there. It's a nice, tidy end. Give me just another second. Let's do a little live chat. Why not? We'll just keep breaking records every time. This is too much fun. My feet are freezing, but otherwise we're good. I'd give you another shot out the window, but the camera's frozen. Still looks about like that, though. This is a live shot, though. Starting to pile up. Uppercase for a couple questions for me while I see if there must be a couple final things I wanted to share with you. Oh, yeah. I'm going to walk home. Yeah. No, Liz is busy at school. She works way harder than I do. Thanks for the question. A couple more questions here. I got one final thing. I've got a couple emails I want to share with you. Paul, there is Loess well west of Lake Loess. Did it come from the Willamette area? I don't know. Good question, Paul. I wish I had that one for Mark. Is it still happy hour while it's snowing in Ellensburg? Yeah, it's happy hour right now. I got to go down and toss a couple back. These are mostly statements that you're including, so thank you. Let's finish. This is a new thought, and I'm maybe going to make you uncomfortable. Oh, here's an email about the cold in the offices. This is from Rachel down the hall. I appreciate the patience. We are limited on staff this week. The issue with those offices due to the main air handler not working. I identified the problem, should have it up and heating early in the afternoon. Early in the afternoon. Okay. Thank you, Loess. I haven't felt it yet. Okay. Email from Bruce. I won't embarrass him. But this is a new wrinkle. I don't know if I'll keep with it, but I've selected a few emails that have come in. This is the last thing we're doing, I promise. A couple emails that I just came in that pertain to today's show. You might find it interesting. So from Ralph. Ralph is a retired Colorado Geological Survey USGS scientist. I can't even read now. But Ralph has been watching, and he's got a lot of stage 6 stuff in the Rockies. I can definitely state that the Bull Lake glaciation in Colorado definitely dates from stage 6. And he's got a bunch of dates here that are going back 130,000 years ago. So a little look ahead to the series. I'm not sure exactly when in February, but I can't stop this alphabet until before we get. I want to do some stuff from the 1960s. There's something called an Inqua conference, where Jerry Richmond is trying to correlate from the Rockies all the way through the Pacific Northwest and even back into the Midwest and come up with some common language and some common themes. So Ralph's email is a step in that direction. Thank you, Ralph. John said, looking at Bretz's field notes in 1922, a pit a mile northwest of Pantops, John is in the Spokane area, and he says, I think that pit might still be open. At least it might have a vertical wall. I may have misread your email, John, if your name is John. It is. So is this some sort of visitor center for the quarry or something? Like, is this something we should be checking out? Somebody over there in Spokane? I know there's too much snow now, I guess, now that I say that. But that Pantops deposit, it keeps coming back to Pantops. And I think we're all agreeing now that it's not glacial till. But if that's one thing you got from today's episode, that do we really need glacial till and a distinct moraine to be confident that we have an ice margin? Does it have to be that cut and dried? And are many geologists in the last 50 years concluding that there never was a Spokane ice sheet in Spokane because they don't see a moraine? It's as simple as that in their minds? I'll say it. Many have said exactly that. People that I value and respect deeply. But they're looking for moraine and nothing else. To me, this is a whole nother way of looking for an ice margin. Is it valid to try to put an ice margin in on a map without having tons of moraine? According to Bretz, it's totally reasonable. Here's Bob. Bob says, here's one of Bretz's 1923 grad students given photo credit. So Bob has followed through on the name O.C. Clifford. Apparently, I shared one of the photos from the 1923 paper, and it was the photo credit was O.C. Clifford. And here's a little bio sketch on Clifford. Received a BS from University of Chicago in 1924. And then went on to work at the Illinois State Geological Survey and other things. So this is the kind of fun tracking down that I was hoping we could do more of as we continue to look for people's names. Okay, that's probably it. I'm getting hoarse. Of course, there's plenty more from Google Earth by Glenn and Google Math by Glenn. That's all waiting for you. Whew! A toast to you. Thank you for joining this episode. How long we've been going? More than 2 hours. Thank you for viewing this one live. Thanks also to those of you who are watching this replay, and that's most of you. But it's so great that you're keeping up with this series. There's a lot going on. It's thoroughly enjoyable for me, and I'm gathering that it's energizing for many of you out there too. So here's to us. One last look here. Hang on. And so, dear viewer, please come back and continue the series with us, live or in replay, on Sunday, January 21st at 9 a.m. And if Jerome is still with us, Jerome, we got to figure out what we're going to do. Do you know anything about those lavas in eastern British Columbia? If not, I don't know what we're going to do. Oh, Jerome, you're still here? And we got to do Zoom, Jerome, so we got to figure that out too. So please email me. We'll find a time to test the AV. Vic Baker from Arizona on Thursday, January 25th. We're going to talk about the ambush meeting and the following summer of 1927 field season. This will be a solo show rounding out the 1920s with Brett's Larry Smith from Montana Tech telling us about the Glacier Lake Missoula sediments as we understand them currently. Sean Wilsey and others booked for February. We'll save that for then. Okay. Thanks, everybody. Hope you enjoyed this one. Thank you. I love you. And goodbye from Ellensburg, Washington, USA. That's a new one. You want another new one? Look at that. See you Sunday morning. Enjoy the rest of your week. Goodbye from Ellensburg, Washington, USA. I love you.